Hello there. Today we're going to fill a large pulverized coal boiler. It's the filling part of the startup operation. The first thing, we've cleaned out the bottom ash seal trough. The boiler expands about 11.5 inches downward. It is suspended from the ceiling. So to seal the boiler, there's a trough full of water by the bottom ash hopper with steel plates. So any ash accumulation has to be cleaned out of there so the plates have free movement. You don't want to come down and hit ash and bend the plates on it. So you have about 11.5 inches expansion from filling with water and thermal expansion. We've made sure all the boiler drains are closed before we start filling. They do get left open and it looks really stupid. We've done a walk down of the system, verified all valves are in correct position. All the valves are supposed to be locked open are locked open. So our valve lineup has been completed. The next thing we'll do is a DCS check to make sure we have all the drops. This is all the DCS. We have 17 drops. We have no alarms. The next thing we're going to check is the alarm removal scan logs. This is really important to do, and every week the alarm should be checked. Sometimes people take alarms out of service. This is alarm check remove. This is alarms they will not alarm. Scan removed, it takes the scan off so there's no indication of the transmitter, whatever you've taken out of scan. So at least once a week you need to go through and verify that alarms are not out of service or something's out of scan. Okay, here's the screen. These are alarm removed. Got a lot of nuisance alarms and other things that have been taken out of service. This is scan, check, remove. Right now you'll have a failure on it. These are all bad quality alarms. So the alarm has been shut off. There's a problem with the transmitter in the field, or something wasn't set up right, so it has been taken out of alarm check. Okay, there's no alarms here that will be detrimental. So like I say, it's a good idea to make sure that you have the alarms coming in. Take something out of scan check, you'll have no indication of the process in the control room. One of the first things we're going to do are roll out the ID fans. These need to roll about 4 hours. We use the drive motor. It's a variable frequency drive on these. So we'll roll it out with something called minimum select. It's this minimum speed on the fans. It'll ensure the shaft is straight. They're fairly large fans. The motor's about 3,500 horsepower. So we'll have our operator go out and verify we're good for a start on them. Come in, Brian.
Go for Brian.
You want to verify the ID fans are good for a start? We'll start with alpha and proceed through delta.
Okay, checking all the ID fans before we start.
Good idea to have somebody walk down all the equipment first, make sure that all the maintenance is done. There's nothing left undone.
Control room, come in. Control room.
Yes, control room.
Looks like all ID fans, alpha through delta, are ready for a start.
Okay, we'll start alpha first.
Okay, cleared for start in alpha.
It's a good idea to announce all plant personnel that you are starting equipment. Attention all plant personnel, starting ID fans, starting ID fans. Please stay clear. That's good for safety and courtesy. Okay, we brought up a graph over here. We have the basically amps, motor speed, motor stator temperature, and average drive current amps. Large motors, you have a maximum time they can run at full load amperage. Produces a lot of heat, and there are limits on how often you can start them. Okay, here's a induced draft fan. We'll put down minimum select. This is kind of like a turning gear. It just allows the fan to run at a slow speed. Okay, we're going to hit start. Go back to our fan control. Pulling 400 amps at least. You can see in our graph it spiked out at 400. It's running 72 RPMs. It's dropped back off. Have our speed. We're only going to show the graph on one of them, but every time you start equipment, it's a good idea to have graphs just to verify it's working well. Here's the AID fan. You have your stator winding, temperatures, bearings, vibrations. Okay, we're going to continue on. Start B induced draft fan. Any of these large motors, there is a maximum time they can run at the start current. Most of these motors run 7200 volts. This has a fairly large variable frequency drive on it, so the draft is controlled by the speed of the fans. The dampers are full open when it's running. Like I say, went about a 4-hour run out just to make sure the shaft, everything's straight on them. Okay, it's the last ID fan. Next thing we're going to check, make sure you have the service water running. This just takes raw water and just provides general cooling water for the plant. The big thing it cools is the aux cooling water. The aux cooling water is a separate closed loop system using demin water. It has corrosion inhibiting chemicals in it, and it provides cooling to all the lube oil coolers, seals on pumps, quite a lot of different items it cools. It is a closed loop system. This is the temperature control valve. Try and maintain the water at a constant temperature about 70 degrees. In the summer it's hard to do as the water coming in starts hitting about 80 degrees. It creates quite a problem trying to get this temperature down. So we have service water and we have the aux cooling water. Next thing we want to do is start rolling out the turbine generator. The shaft of this thing is, I don't know, probably 120 feet long. You can have 3 mils eccentricity. It's not on turning gear. We have the AC lube oil pump running and the hydrogen seal oil skid pump is running. The generator is gassed up with hydrogen. Should have about 55 pounds on it. So the hydrogen cools the generator, and there's also cooling water in the stator windings. So we have the high pressure turbine, intermediate pressure turbine. From the intermediate goes back to the boiler is reheat. The steam is reheated up. From the HP they'll feed the IP turbine. Exhaust from the IP goes to the 2 LP turbines. Also the exhaust from the IP runs your boiler Feedwater turbines. So the exhaust out of the HP goes to the boiler, is reheated to about 1005 degrees. It comes back through the IP. More of the heat energy is extracted. The exhaust steam from here goes to LP. There's 2 LP turbines with surface condensers underneath them. This has bearing lift pumps. Use high pressure lube oil to float the shaft off the bearings. When the shaft is running, it'll produce an oil wedge and it'll float on that oil wedge off the bearings. But at slow speed, you have a lot of weight here at the generator. So in order to prevent bearing wear, we use the lift oil pumps. Okay, they're all stopped. We'll hit start on them. So this will actually float the shaft off the bearings with the hydraulic pressure of the oil. Now, place on turning gear, we'll have our operator stand by just to verify there's no rubs. Come in, Brian.
Go for Brian.
Yeah, we're going to push the turbine generator on turning gear. How you want to go out there and verify everything's okay when we start the turning gear?
Okay.
We have eccentricity meters that watch the eccentricity on this. Okay. It's on turning gear. We have the vibration meters back behind us so it doesn't show up on the screens. Eccentricity's on there. Okay, next thing we're going to do is start the Circulating. These pumps here take water out of the reservoir, have a traveling screen, trash rack in front. They're about a 2,000 horsepower motor. Pump about 90,000 gallons a minute each pump. They feed the 2 surface condensers. There's a vacuum pump that sits on the top of the raw water in the surface condenser. There's a seal well structure, so it can produce kind of a slightly negative pressure on top of the surface condensers. The purpose of this is to produce a slight siphoning effect to minimize the power it takes to move the water through the condensers. So this lowers the head on the pump that it needs to produce. So I'll have our operator go down and verify the pump's ready for a start. We'll probably just start one for now and start that when we get up to higher power levels. Come in, Brian.
Go for Brian.
You want to verify a alpha circ water pump is ready for a start?
Okay.
These pumps don't have check valves on them, so the discharge usually will close where the pump shuts down. Or for startup, it opens about 10%, pump starts, and then it goes full open in about 9 minutes just to keep from hammering the system from hydraulic hammer from starting the pump. These lube pumps, they provide water to the shaft. There's a rubber bushing on the shafts, so we use filtered water to keep dirt out and to cool and lubricate the shaft bushings. There is a trip on the pumps if we lose it.
Control room, come in, control room.
Yes, control room.
A Alpha circ water pump is ready for a start.
Okay, A alpha circ water pump ready for start. We'll go ahead and start lube water pump. This is the start permissive for the pump. Attention all plant personnel, starting A alpha circ water pump, starting A alpha circ water pump. Another consideration, you want to make sure all the water boxes are closed, all the drains are closed. When we start a pump, we'll have an operator go out and verify there's not water leaking. Okay, as you can see, it's pulling quite a lot of current on this motor. It's back down. Now the discharge valve is starting to open. This is a butterfly valve. It'd take about 9 minutes for it to get full open. Like I say, you don't want to water hammer the system. It allows the pipe to fill. These lines are pretty large. You can actually walk down them. With 2 pumps, you put about 180,000 gallons a minute of water goes through this. We'll go ahead and start a vacuum pump. These are liquid ring vacuum pumps. Usually we run all the A pumps. B's for backup. They're tested monthly. Well, samples are taken, vibrations are ran. So every month we'll swap and run these for 24 hours just to verify everything's fine. That way you have one good pump. If we lose this pump, then we know this pump here will carry the load while we rebuild it. Okay. Now we have water going to condensers. We can start the aux boiler. The steam traps from the aux boiler come back to the surface condenser. So you have to have water on it first before you start warming up the aux boiler. The aux boiler's purpose is to peg the deaerator, which is heat the deaerator water up, drive off oxygen so you can deoxygenate the water before you start filling the boiler, and also provides seals for the steam turbine. This turbine self-sealing once it gets up and running, but to start with we'll need the aux boiler. Come in, Brian.
Go for Brian.
Okay, you're good to start the aux boiler.
Alright, starting the aux boiler.
It's a diesel fired boiler. So we probably better turn the igniter fuel oil on. This pump provides diesel fuel oil for the aux boiler and also provides igniters for the coal burners. Okay, you should be good to start the aux boiler. Another system we need to start, electro-hydraulic control system, EHC. This uses oil under high pressure to operate all the turbine valves, the feed pump and the main steam turbine valves. So we'll go ahead and start this. We can't put the other pump in auto until it comes up to pressure. It's going to auto start the pump. Use a special hydraulic oil, non-flammable type, because you're running hydraulic valves over your steam turbine valves, which can be 1,005 degrees. So all the turbine valves are hydraulic operated. They have spring assist for closing quickly, and the oil's dumped fast. So during a trip, they slam shut almost instantaneously. Should build it around 1600 psi. Like I say, this runs the feed pump turbines, 2 of them, and the main turbine generator. The stop, governor valves, reheat, stop, and intercepts. We should probably let this build up to pressure and put the other one into auto in case we lose the pump. Okay. One thing you always want to do is make sure all your pumps are in auto. The start of every shift, go through all the screens, verify everything's in auto. It's set up correctly. Okay, we're going to bypass the low pressure Feedwater heaters. That hasn't been done yet. They really don't do any good until you're up to probably 120 megawatts. And we're going to put boiler water chemicals in, and they're brass tubes, so you kind of want to keep that out of them. Come in, Brian.
Go for Brian.
Yeah, you want to bypass Feedwater heaters 1A and 1B at the local bypass valve.
Okay, bypass the Feedwater heaters, 1 Alpha and 1 Bravo.
Okay. These are the bypass valves here. You'll bypass these 2 Feedwater heaters. These are located on top of the surface condenser. So they take extraction steam off the low pressure turbine. It just helps improve the plant efficiency. Okay, we're going to bypass Feedwater heater 2. This one's in top of the surface condenser also. The reason you take extraction steam, as the steam expands, your turbine has to be physically too large. So you take part of the steam and use it to heat the feed water, reclaim the heat energy out of it. Okay. We have the chemicals mixed up for the startup. We're going to start filling the surface condenser. One problem you have, we're going to be using auxiliary steam to peg the Deaerator, which is right here. The steam will condense and add water to the system, so you don't want to start out with too much water because you're going to gain quite a bit as you heat it up. The condensate storage tank has 20 feet. Diminished storage tank has 28. Usually we make up to the diminished storage tank. This is from a demineralized system. And then the water is verified that it has low conductivity and the pH is okay, and then it's transferred to the condensate storage tank. Just kind of a safety check to make sure you have good water going in. This is the level control valve. There's two types of level fill on the condenser. Normally, it's all gravity fed, but this valve here will be located down low in the surface condenser, so the water will gravity feed down to the condenser, feeding in the bottom. Once you get vacuum and running, we have what we call a drag valve. Condenser vacuum will pull the water in. The water going into a low vacuum environment, the oxygen will be released. It helps partially aerate the water. Set point set at 43. We can't change this. So we'll do something that you want to be careful about doing. We're going to take it out of scan, which means it won't be reading this anymore. Scans off. We have a bad quality signal coming in. Now we're going to type in 37, just lowers the level a little bit. This is kind of a neat screen. You have your value status. You have the alarm. This is where you take the alarm check off. Cutouts. Instrumentation shows you all the scale, maximum values. Nothing in the limits. Configuration. Here's your point ID. Analog kind of tells you about point numbers and stuff. There's a lot of information here. Okay, as you can see, we have 37s entered. It does show that it is been forced. Okay, we're going to start filling the Hotwell. We start filling it. We have our chemistry recs of what they want to put in the system. We'll put half the chemicals in the surface condenser, and then we'll add a hydrazine or an amine type product before we start filling the Deaerator. This will be pretty much just hydrazine going here, an oxygen scavenger. Come in, Brian.
Go for Brian.
Yeah, you can start adding chemicals to the Hotwell per the chemistry rec.
Okay, and chemicals to the Hotwell.
This valve moves really slow, so you have to. We'll drive it down close before we put it in auto once we get close. Since there's no pumps, we can add water pretty fast. We'll have to set up now for starting a condensate pump once we get around 37 inches, then we'll start a condensate pump. These are the polishers. They're bypassed. We won't put a polisher in service until we're pulling vacuum on the surface condenser. It strips out the oxygen. Otherwise, you'll foul the resin, the oxygen will get pulled out and okay, the air level control valves. We're going to drive this down to start about 10%. Just to keep from hammering the system and hold down the current load on the condensate pump motor. Yeah, overshot a little bit. This is the pegging steam valve. We'll use this once the aux boiler is running to put steam to the deaerator. Normally this is taking extraction steam off the low pressure turbines, about stage 16 of them. So it's used to heat the deaerator. The bleeder trip valves, all these Feedwater heaters have a bleeder trip valve on the steam side. It prevents water from going back into the turbine. The Deaerator has 2 bleeder trips. There's so much energy here that if you did not have a check valve, the turbine tripped, this water would flash to steam. There'd be enough energy to drive the turbine to catastrophic failure. There's also a motor operated valve on this steam line high levels. It'll close. The bleeder trip's main function is to keep steam and water going back into the turbine on a turbine trip. This is the Deaerator drain valve. We'll use this to circulate water through the system while we're pegging, just try to clean up the water in the system. Usually this is set about 40%. We'll close it while we're filling the deaerator. This makes it a little bit quicker. So we'll circulate water through the condensate system until we're about 220 degrees. The chemistry looks good on it. Then we'll go ahead and start filling the boiler. I guess we can go a little bit more on this one. It don't make a whole lot of difference once you get in the upper range of valves. There's not much more flow. The whole filling process of the boiler will take 11 feet of water. Other CST about 110,000 gallons of water. Each takes about 2 hours. One thing, you want to make sure all the level transmitter legs are full of water, especially after a long outage. Otherwise you won't have level indication. So you need the low and the high legs both filled to give you an accurate level. While we're waiting for this, we're going to close down the boiler drains and check valves. We got the vents open. All the vents have been set up for firing on this. The vents and different drains have already been done. These are the Condenser recirc valves. Provides natural circulation when you start firing the boiler for the economizers. Water comes out of the drum and circulates through here just to keep from forming steam. These are the division wall drains. They're open. We'll close them after we get started. Just don't want any moisture going in there. This is the boiler drum level control screen. 3 transmitters on each end. It takes an average of these. You can take one out. If you have a problem with level transmitter A, you can override it and just run on B. So it takes an average of these 2. And then here's your selected drum level. It takes another average. It figures in the pressure. 3 pressure transmitters on each end of the drum. This is the continuous blowdown. We'll go ahead and close that for now. This is normally ran when the boiler's running. The line is right below the surface of the water. So I figure that's usually the highest concentration of solids. The water goes down to a flash recovery tank. The steam from here goes to the Deaerator. And the water from here is fed down to the surface condenser where it's cleaned up in the polishers. This is the mass blowdown. This just dumps water. If you have really bad water quality, it dumps it to the atmospheric blowdown tank and the water is wasted. These are drain valves. When you start up, you want your drum as low as you can get it and still maintain permissives for starting igniters and pulverizers because the water will expand. So if it expands, you can use these and drain water out of the boiler. These valves here normally aren't used. We'll drive them closed. So this part of the boiler should be good to go. We're at 32 inches in the surface condenser. So we have our electromatic valves on the top. They're a relief valve that can be opened from the control room. This is on the finishing superheater outlet. Usually you want your safeties on the outlet of the boiler to go first. That way it keeps steam flow through all the tubes. These are closed until we get up to higher pressure. So these electromatic relief valves. These are the first ones to relieve on the boiler, and they can be opened manually if you need to. Okay, back to the condensate. We're going to start backing this valve down. If we put an auto right now, it'd overshoot bad. The valve moves too slow. It's tuned to move slow because usually the changes on this system are not really fast. We're going to go ahead and start a condensate pump. Actually, I'm going to leave this open just a little bit more. We'll overshoot a little bit, but that's fine. Yeah, I better go. It'll give the valve a head start in auto. Okay, we're going to start a condensate pump. Come in, Brian.
Go for Brian.
Starting A alpha condensate pump.
Okay, we are ready to start a alpha condensate pump.
Okay, ready to start A alpha condensate pump. Attention all plant personnel, starting A alpha condensate pump. Starting A alpha condensate pump. These have a check valve and also called arc valve, automatic recirc control valve. So they maintain recirc flow back to the surface condenser. This valve, same scheme, it opens a little bit, the pump starts, and then it slowly opens the rest of the way so you don't slam the system with full flow. Same thing, you should have graphs up on all these when you start pumps. Pulling 100 amps. Bunch of high amp alarms. Say this valve is slowly driving open now. Base the water goes through the polishers. These are a dual bed resin. Has cation, anion in the same vessel. You have to move them to a vessel when you regenerate and split the anion from the cat, then regenerate the cat, and regenerate the anion, and add them back together. Here goes your Gland steam condenser. Any excess Gland steam is condensed. That's a little bit to the feed water. Deaerator level control valve goes to your low pressure feed water heaters. 1, 2, and 3. Then goes to the deaerator. We'll have to really watch our level. We're pulling pretty good. Control valve moves really slow, but we're okay yet. This is about 12% open, which looks like it'll work good. We'll open up more once we get under control. We're only putting out 25,000 pounds an hour of flow, so. Probably not a bad idea to let the motor run kind of loaded for a few minutes, cool down a little bit. Still not grabbing the level on the surface condenser. You can always put it in manual, drive it open, and throw it back into auto if you have to. Okay, Feedwater screen. We're going to set these valves up for when we start at feed pump. There's no level control valve normally when you're running. Your feed pump turbine speed down here controls the level, so the speed of these pumps is driven from the level. This is the startup feed pump, a little electric motor pump. This does go through a control valve. This boiler runs single element until you get to 1400 psi, then it swaps over to 3 element, which looks at steam flow, feed water flow, and drum level. So to start out filling it, we'll use this valve here. Once we get running, we'll open this valve up, and then it'll just run on the feed pump speed. This is the main seal water for the pumps. We have 15 pounds. That comes off the condensate pumps. This has the rest of the feed water heaters. Deaerator is considered feed water heater 4. And you have feed water heater 5, 6, and 7. These are taking extraction steam off of the IP turbines. Looks like the level's still dropping. Yeah, we'll help it a little bit. Put it back up. Okay. Now we're gaining. Our current's still good on the condensate pump. Just have to watch the condensate level and the motor amps on the condensate pump as we're filling. That's quite a bit of water flow there. We're starting to get a level in the Deaerator. Probably going to have to back this down. We're over pumping the surface condenser. It'll take a minute to see the change in the surface condenser. We'll see what this does. See, the motor amps have dropped off. Winding temperature still coming up. Being about 1,000, maybe say 1,000,000 pounds per hour. Deaerator has trips on it. If you get down to 65 inches, he'll trip. It won't let you run the startup feed pump. Basically, at 67 inches, they'll trip one feed pump, and 65, they'll trip the other feed pump, and you won't have the permissive to run the electric startup feed pump. That's protection for the feed pumps. Also, high level will close the steam valves to the deaerator so you don't get water back to the turbine. Like I say, normal deaeration steam is from the low pressure turbines, stage 16 extraction steam. Looks like the level's starting to hold. We just want to make sure, set point's 100. Just want to keep the water down as low as you can in the system when we're starting to peg it. Otherwise your levels get too high on you. See, the condensate storage tank is pulling down. If we have to, we'll transfer water over from the demand storage tank. We'll look at the aux boiler. This screen here is your aux steam control. You have intermediate superheaters. This comes off. Basically, the division walls is used for startup or emergency use. So this is usually under like 2400 psi steam. Goes to letdown station and feeds your header. It's mostly used for startup, low pressure. The cold reheat's what normally feeds this. This is coming off the high pressure turbine exhaust. So it comes down through a letdown. The pressure on the cold reheat seems to follow the megawatt somewhat. So if you're at 120 megawatts, you got about 120 pounds pressure. You get up to 600, it hits about 600 psi. You have your pulverizer inerting steam, boiler DA, carbon filters, different things take steam off the aux steam system. You also heat up the caustic used in the polishers and the demineralizer, anion resin regen. It has to be heated about 130 degrees. It seems to strip the silica off better. Have electrode boiler for plant heating for when the plant shut down. And we have the normal plant heating coming off the aux steam, which feeds cold reheat. Have 160 psi in the aux boiler. Looks like we're good to take steam once we get more level in the deaerator. Still taking a little too much water. Take a couple more clicks off it. Once we get more level, we'll start sending water back to the surface condenser, start recirculating the water through the system. Once we start opening this valve, it's going to close down the fill valve. You'll have water flowing in the system. I say we have to be above 65 to get the start permissive for the electric feed pump, which will be used for filling the boiler. want to get to at least 65 before we start pegging. We could put the feed pump turbines on turning gear, but we won't be needing those for a little while. They're a smaller turbine, so they roll out pretty fast. I think they put about 13,000 horsepower each one. The Deaerator level control valves, first this one goes open, and if they can't keep up, then this one goes open. So they kind of gang, so they work together so it maintains all the water you can to the Deaerator. Usually I'll run 2 condensate pumps when the plant's running. You have to have 2 running at 300 megawatts to provide enough water. Problem filling the boilers, it takes quite a bit of time. The actual filling of the main boiler takes at least an hour and a half. We'll definitely speed that part up. These are the turbine drain valves right now. These are the main steam drains. For startup, these will be opened. They'll send all the steam back to the surface condenser, so you warm up the steam lines to the high pressure turbine. Keeping water out of your steam turbine is critical. Have these drain valves that are used for startup. This is where they go to the surface condenser. There's also orifices that send a small amount of steam back just to ensure there's no water building up. Also some traps on these. These close automatically. About 120 megawatts, they'll all go closed. You have your ventilator valves. Get rid of any excess steam when it shuts down so it doesn't overheat the turbine. If you have steam in there and the blades are trying to compress it and beat it, it produces heat. Check the seal oil real quick, the seal oil system. Somehow we have our DC pump running. DC pump runs off 125 volt DC from a battery bank. There's several pumps, the lube oil pumps that are set up like that. Huh. Yeah. Okay. Basically, there's 2 parts to the seal oil. This part here is on the hydrogen side. It's a ring with holes so the oil goes in. Part of the oil flows in and comes down the hydrogen side tank, and the other oil comes out to is collected. Then what isn't collected ends up with the bearing oil. So there's a loop seal and vacuum pump stripping hydrogen out of the lube oil that's going back to the reservoir. You have your air side pump, which takes lube oil and feeds up to the seal basically. Then the hydrogen side takes it out of the hydrogen side tank and feeds in to the hydrogen seal. We got about 60 pounds pressure on it right now. Okay, 59 inches. We have pretty good water flow through there. We're going to open the drain about 40%. This should start backing off the level control valve when we do this, because part of the water now is going back to the surface condenser. Not paying attention, overshot that one, but anywhere in here is fine. Maintaining pretty good flow. We're going to start pegging. Okay, we're opening up the pegging steam valve. Now we need to watch how much steam flow is coming out of the aux boiler. Up to 12,000. We really don't want to go much over 24,000. $13. We really don't want to put this in auto yet because it's going to go wide open and the condensate pump will run out. It won't be able to keep up with the flow. We'll increase the pegging a little bit more. Usually take quite a lot of pegging steam. Big thing is not pulling too hard on the aux boiler and tripping it off the line. Up to 20,000, 21. I have the operator now open up, make sure all the gland steam drains are open so we can start warming up the gland steam system. Come in, Brian.
Go for Brian.
Yeah, you want to make sure all the gland steam drains are open, feed pumps, main turbine, so we can start warming up the header.
Okay, checking the gland steam valve.
Okay, you have to start the exhauster. This just pulls a slight vacuum on to get rid of any air, non-condensables. Basically, the turbine will use aux steam to start up with. It will seal the turbines. Once it starts up, we'll use main steam next and cold reheat. And once you get up to higher loads, then it'll have spillover. This is steam going back to the surface condenser. There'll be enough leakage steam from the HP to seal the LP turbine. Have a desuperheater to maintain the temperature on the gland steam so it doesn't get excessive. Gland steam temperature is pretty critical. And one thing you don't want to do if you lose gland steam and you got a vacuum, you want to break vacuum so you don't pull a bunch of cold air over the shaft and cause cracking. This valve doesn't control too good, so we're going to go 3% on it. This is pressure control and this is temperature control. Desuperates both the feed pump turbine and the main steam turbine. They're set at different temperatures. Okay, this should be an auto. So it's a good idea to check the screen to make sure stuff is in auto and where it should be. Make sure this thing is in auto 4 psi. Okay, 80 inches. It's coming up pretty good. I think we can probably get away putting this thing in auto. And this valve moves really slow. Yeah, I'll give it another minute, I guess. Yeah, I'll see what it does. Okay, that didn't work. As you can see, first this one valve goes 100%, then the other one will start opening. So that's a good demonstration how the level control valves work. Say this one will go 100%, and then this one starts opening. You can change the lead on these. If you wanted B to be the lead, you'd change it here. Right now, A is the lead. Check the aux boiler, 22,000. Better look at gland steam, it's probably going up. I'm not showing anything yet. Two inches. Take a little more steam. So we're about 100 degrees right now, 101. I say we'll have to pull vacuum on the condenser, then we can put the polisher in service. So we're getting the gland steam seals ready to go. Without gland steam, you can't pull a vacuum on it. And if you lose gland steam and you're pulling a vacuum on the condenser, you got to break vacuum. The cold air going over the shaft can cause cracking and other problems, and some warping and rubbing. Okay, we're getting close. Try this. Yes. Okay, it seems to be holding auto. This valve should start going closed once we get to 37. We'll have to put this in manual and drive it closed. It will overshoot. Gland steam got half a pound on it. It's coming up. You also don't want condensate and the gland steam going back into the seals, so it's important to have all the drains open, warm everything up. The condensate from the gland steam condenser goes down to a collection tank. This collects sample water from the lab and a few points, and it sends it back to the surface condenser. It has a level control valve on it. Since under vacuum, it pulls it through. Without a level control valve here and didn't have water in here, it'd just suck air in. Okay, you can see the level control is closing down. The automatic recirculation control valve should be opening on the condensate pump, sending water back to the surface condenser. It's automatic operated valve. It's a arc valve and also a check valve, automatic recirculation and the check together. Okay, we're 110. Level's starting to come up now. Try and get the gland steam in auto as quick as we can. It's a good idea to have everything auto as fast as you can, because if it's in manual, it's going to get missed. So it's best to run in auto. I'm going to put a trend up. Okay, we got our gland steam. Over here is a trend, which is really helpful. Trends are really a helpful tool. Can show you what's going on in the plant. You can also troubleshoot with them. Steam 23,000. That's a pretty good number. If we had to right now too, we could also do regens, demin, and polisher. We have steam. We could have heat the caustic up. Like I say, hot, warmer caustic solution works a lot better for regen the anions. Level's not coming up too fast. We'll look at the feed pump turbine lube oil. I suppose we could get these on turning gear while we're waiting. Come in, Brian.
Go, Brian.
Yeah, I want to put both feed pump turbines on turning gear and make sure the warm-ups are open on them.
Okay.
Warm-ups just take a slipstream of water off the discharge to keep warmer water in the feed pump when they're shut down. We have to start when the lube oil pumps. Once again, you have to wait for pressure to come up. Okay, alarm cleared. We have a vapor extractor, gets rid of any oil vapors out of the tank. And it creates a slight negative pull in the tank, which keeps oil vapor from coming out to the turbine room. Okay, it should be safe to put this guy in auto. These have DC backup also for lube oil pumps, 125 volt DC. These are used for emergency shutdown if you lost all the power in the plant. These would run to get the turbine down. You need to keep lube oil on these because there's quite a lot of heat in the shaft and it's preventing the babbitt from getting melted in the bearings. Okay, we put him on turning gear. Once again, we'll check the eccentricity on the vibration panel. See, our gland steam isn't going very fast. These have thrust bearings. I think at 18 millimeters it will trip, so you don't crash blades and bearings. The feed pump has your main feed pump driven off the feed pump turbine. They can run up to 5,800 RPM. The high level shutdown on this is 3,400 PSI. Normally it'll run at least 3,000 PSI. And they can pump about 3,500 gallons a minute. There's a reducer that drives your booster pump. The booster pump runs about 3,600 RPM when this one's running 5,800. It's like a 1.22 gear ratio. Lube oil coolers. You don't want to start these with cold oil. That's really that's worse than Hotwell machines. The pump shouldn't start with the wells below 50, and the turbine, the warmer the better. So by running the lube oil pump stuff, we should heat the well up a little bit. Cold oil creates vibrations in the bearings. Your lube oil wedge becomes too thick. Okay, we'll start. A lube oil pump. Once our alarm clears, we can put the other one in auto. Like I say, it's critical to have all the equipment in auto. Especially if all the startup stuff gets missed. So if you're coming in behind the guys that started the plant up, you definitely want to go through all the screens and really check everything. Okay, lube oil pumps are in auto. Put this on turning gear. Yeah, a little bit more gland steam. Right now we're just using the manual valve on it. We want our graph here to start coming up. Once we close the drains too, he'll come up a little faster. Yeah, it's moving pretty fast. Plant operator will close the drains once they're issuing steam and take all the moisture's out. It's one of those points where one click is too much. Taking a click off is not enough. $138. Got 2 1/4 on the steam. Once we get close to 4 pounds, we'll go ahead and open this valve. Okay, check the aux boiler. 24, it's about where we want to be. We're coming up pretty fast on the gland steam. pulling about 17 inches water column vacuum. That's about where it wants to be. There is a little butterfly valve that can be adjusted. Okay, we're going to open this guy. It is an auto. Boy. Drive this down. I'm going to check the electrostatic precipitators. These are the TR sets. I just put the power out to the plates and knock any particulate out of the flue gas. Just want to make sure the wrappers are running. And they are. These need around about 4 hours before you put fire in the boiler. You also have to call the clean air people too before you start. Okay, we kind of cut the filming there because it was pretty boring. Getting ready to start again. What we've done in the meantime, we moved 15 feet of water from the Dimin storage tank to the condensate storage tank, so I have more water for filling the boiler. It'll take like 11 feet of this, 110,000 gallons to fill the boiler. At this point, you can start the Dimin unit up again. Usually we make 15 feet of water at a shot. It's a demineralizer, somebody will start that, and we'll fill this back up. The next step, we need to start pulling vacuum so we can put the polisher in service. Make sure gland steam's okay. Gland steam's good. Set this thing up to run. Aux steam was 4. Main steam is 2.9. Cold reheats, the normal one will take once we get going. And set 5.1. And the spillover. it's set for 6.3. It's going to dump steam to the septic condenser because there will be excess steam once we reach full load. Okay, we're going to start the vacuum pumps. These are our liquid ring sealed pumps. They're 2-stage. Normally you have the first stage and they'll feed the second stage to pull the vacuum. When you start up like this, they go into hogging mode. So both first and second stage will pull together. We have a vacuum breaker. This is used to break the vacuum on the system. We'll go ahead and close it. We'll have our operator just check out the pumps, make sure there's water in them. Come in, Brian.
Go for Brian.
Yeah, getting ready to start both Alpha and Bravo vacuum pump.
We're ready to start both vacuum pumps.
Have check well levels on them, the gearbox, make sure there's water in them. They use water to provide the pumping action. There's just a scroll cage in here. The water comes in as the water is compressed, then expands, it pulls air in, then it's compressed and sends the water and air out. Pretty good pump, they're pretty durable. Vacuum breaker's closed. Hit start. This is a little pump here that it takes the air in here and water from the seal cooler mixes, so then the water air mixture goes to a separator tank, and there's a little pump that pumps the water back to the seal cooler and back to the pump. We'll run both of them to start up with, and once we reach vacuum and running, then we'll shut one down. It's also been thought that if you have a time like in the summer when you're a little low on vacuum, it may pay to run both vacuum pumps, pull a little higher vacuum and get a little more megawatts out of the unit. Probably would offset the power cost on running the vacuum pump. Okay, 207. I put this in manually, it was swinging too bad earlier. The next thing we're going to do is put a polisher in service. Well, the labs told us that B would be the next one to run. It has the most hours on it, so we'll go ahead and run that for startup because it will take a beating. Before we start filling the boiler, we'll have to send chemicals up, the rest of the chemicals to the Deaerator. Okay, we're starting to pull vacuum. The turbines do have trip on, high vacuum. Pretty much any condensing turbine does. Produces too much heat and windage on them if you run high vacuum. It needs good steam flow through them to provide cooling. Come in, Brian.
For Brian.
Do you want to put B Bravo polisher in service?
All right, putting polisher Bravo in service.
Once we get this in service, we can close the bypass. Bypass is set up on high DP to open. Usually we'll rinse them down first, send water through back to the surface condenser for a while. We put it in service when the plant's running, but right now it's startup, so we'll just go ahead and put this one in service. It has the most runtime on it. You have to equalize the pressure on first before you open the valves. This high of pressure, if you don't equalize the pressure, it can do damage to the resin, crush it, and do some weird things. Deaerator's 209 degrees, that's pretty good. Okay, you can see the flow starting to come up on it. So he's putting it in service. Once it kind of stabilizes, we'll start closing the bypass. I might just take it kind of slow. You can close these and hit stop, kind of control the travel. Just keep from slamming the vessel with full flow. Okay, you only have 312 gallons. As a valve gets further to being closed, it's going to have a greater effect on the flow. Okay, we're pretty much there now. Polisher in service and pull and vacuum. You let this thing run a while to clean the water up. The chemistry lab will be watching that and give us the okay when to go. At this point, we're going to go ahead and start getting ready to fill the boiler. Before we do that, we're going to make another trend. These are the economizers. So as this warm water comes through, as soon as the lower economizer fills, this temperature here should start rising. Make a mini trend. You can add a whole bunch of these to one trend. You start. Now we got the add, so we can go over here and grab the next temperature. Have to add point every time. We have the lower drum temperature and higher drum temperature. This way we'll be able to tell when it's filling up. And we'll throw the drum level in there. Big thing is to stop before you get too high of water in the drum. Otherwise you're going to have to deal with high level once it heats up. Okay, this should tell us once the lower economizer is full, this temperature will start coming up. your upper countermiser's full, this will start coming up. Once you get the water through all the tubes, water wall tubes up to the drum, this one will start climbing, and then you'll start seeing it on your level. We want about a minus 4.5 inches when we're done. Okay, we'll apply this. And there's our trends. You can change the ranges on this too, if whatever you wanted. It would work best for tracking it. Okay, polishers in service. Let's see what kind of a vacuum we have. We're still pulling down. We got 25.7 inches mercury vacuum. It should pull down to at least 28 probably. This here's the absolute vacuum. 4.1 inches mercury absolute. There's a lot of different ways of measuring vacuum out there nowadays. This used to be the old standard. Okay, we're going to add the chemicals to the Deaerator, then start filling the boiler. Come in, Brian.
Go for Brian.
Yeah, ready to add chemicals to the Deaerator.
Okay, adding the chemicals to the Deaerator.
This will be hydrazine and amine. We'll go ahead and close the drain valve so we don't send the chemicals back to the Hotwell. Strip them out in the polisher. Okay. We're going to start the electric feed pump and start filling the boiler. Come in, Brian.
Go, Brian.
Yeah, ready to start the electric feed pump and start filling the boiler.
Okay, you're cleared for a start on the electric feed pump.
Attention all pump personnel. Starting electric feed pump. Starting electric feed pump. Once these lines are full, they'll have to come and unpin the hangers. The hangers on the condensate lines are pinned when we shut down and drain it. Puts too much stress on the piping. So they'll pin the hangers so they can't move. Once the line's full, they'll come back and unpin them. This is the same type of pump. It has an arc valve, automatic recirc valve on it. So we're just going to go ahead and start it. It's only good for about 1200 psi, so going to go ahead and open up the block valve to the control valve. Sure, it's on about 1000 psi across the valve right now. We're basically limited on the flow as how much the feed pump can take, can't overamp it. Has a manual reject in, MRE. That valve has to be full open before we start moving LV7. Manual rejects just mean the plant has defaulted back to a manual mode. Okay, MRE is cleared, valve is full open. This valve's set to drive closed, so Have to get past 15 really to get any flow on it. Once again, we'll have to play with our Hotwell level control valve. K24, we're starting to get flow through there. Pressure's dropping across the valve. Motor amps are coming up. So here we're just playing with the flow and the motor amps. Can't pump too much because, yeah, we got too high there. Trying to hold the motor amps right around 53 or something. There. I'd like to have about 800 gallons and 1,000 pounds per hour flow. Okay, we'll let that settle out. The big thing here is just to keep the water hot. We're getting good deaeration now on it. We should be starting to pull out the CST, or condensate storage tank. Like I say, we moved water over to fill it because we'd have gotten too low once we filled the boiler. Hotwell's starting to drop. About 24,000 pounds an hour on the aux boiler. Goes a little bit more on the startup feed pump. When you start the plant up, they have a time that they want you online at, so all this has to be choreographed. Usually took about 48 hours to start the plant up from cold, get everything running. But usually they'll give you time, usually around midnight. They want you on at midnight or some set time, otherwise you have to buy power. So balance authority operator and merchant people, they have to balance the power loads for the grid. Either buy power or run other plants more. Okay, levels coming down. So it'll probably be around 18 feet when we're done. Deaerator temperature's holding. Like I said, this will be the first temperature to change once we're full. It's coming past the Feedwater heater right now. It's starting to heat up. This would be Feedwater heaters 5, 6, and 7. You see the temperature starting to climb. Probably a little bit of flashing of steam. And at this point, mostly just babysit it. It's a good idea to know how much water is going to go in, how long it takes at the flows, in case the level transmitters aren't working. Has been problems where the legs weren't filled and we didn't have good indication. Once you overfill a drum, it's hard to get the water back out of it. So this will take probably about an hour and a half to fill. And at that point, we're ready for the next step on this. We'll probably stop the video here. It's not much to see. Like I say, we'll watch our trends over here. You can tell when the different economizers fill up. When the drum's getting full, the temperatures will start changing on it. And we'll stop filling when we get about minus 4 inches or so. We just have to clear the permissives for the igniters and the pulverizer for the next stage of startup. And that's about it for this video. These are kind of long, boring videos. We're just trying to documentate how the plant ran and all the steps on it. Anyhow, have a good day.